Good morning, everybody. Hey, this thing's on. Welcome to day 4 of PDC. Thanks so much for coming this morning. I know after 3 days of a conference, I'm not always excited about getting up for an 8:30 session, so I really appreciate that you're all here today. And I work on a pretty small team at Microsoft, so I know that most of you are not my coworkers. I really appreciate that too. I know you guys have heard about the memo that every session has to have some kind of picture thing in it somewhere. So I just wanted to get a little bit of proof that there's so many people interested in Sync this morning. So I've hooked up my phone to my PC so that I can project, and I'm just going to switch into the camera mode here and hope that the bright lights don't wash you guys out. So since it's morning, I want you guys to wake up. Everybody, on the count of 3, you're going to say PDC, wave your arms in the air. Make sure those guys in the next room can hear you. So really good. Should we practice before I take the picture? Or you think you can do it? You can do it. OK. So let me line you up here. I'll try to get as many of you as possible. All right. So 1. Are you really ready? OK. All right. 1. So it's PDC. OK. And you got to wave your arms so it shows up in the picture. OK. 1, 2, 3. PDC! Shutter lag. Oh. There you go. So that's pretty cool. It's fun to have the picture on my phone. But let's see what else I can do here. So, oops. There we go. So as you can see, I'm actually running the mobile live mesh client that we've told you about. And in fact, I'm pretty sure this is the first time that anybody has demoed this anywhere. So go ahead and take a picture of that. So I've got basically the mobile live operating environment for Windows Mobile 6.1 running on the phone. And it's actually syncing up to the cloud. So if I come over here, let's get out of the projector mode. And let me bring up my live mesh desktop. And if all goes well, so there's the mobile pictures folder that I'm syncing. And it's thinking. There we go. So image 204, that's the one. Now, hopefully you guys have seen the Silverlight Media Viewer. So I can actually cycle through the pictures. And there you guys are. Cool. So like I said, that is the first ever mobile to cloud to PC sync demo that you'll see. So thanks for being a part of it. And of course, the cool thing is now that picture is off my phone. It's already in my live folder. So I can go, invite people to the folder. I can send my coworkers mail and say, hey, this is really cool, right? Hopefully you've seen this before. So now I can just invite people, and I can share the photo. And I can walk around the conference taking pictures, and they'll keep on syncing up to the cloud. And of course, any device that I have in my live mesh, so I can add my laptop, my home PC, they'll all be syncing it down from the cloud as soon as I take those pictures. So there is, I will admit to one little demo trick, which is that I set the phone device to be watching that picture folder and syncing every time I take a picture. I'm pretty sure that if I left that on, my battery would be dead, fast. So there's a setting, I tweaked it all the way up, but basically, I typically have that sync every half hour, every couple hours. For a desktop, it's not a problem. But for a mobile device, you'll collect them a little less often. Still a very cool thing. And so that's what this session is all about. If you think about how that happened, I had some bits on my device. I synchronized them up to the cloud. And then Live Mesh is going to synchronize them around to all the different devices in my device ring. And so what I'm here today to talk about is FeedSync and Live Mesh, and basically to tell you how you can do this in your own applications. So in a previous life, I was in the Microsoft Developer Division for a really long time. And one of the most common questions that we'd get asked is people would look at Outlook and Exchange and Outlook Web Access, and they would say, hey, that's really cool. We talk about offline application scenarios, and they say, well, couldn't you just give me some components, some controls and server pieces to make my app work like that? And we'd always say, yes, we'd like to do that. So it's just something that as developers, everybody wants this capability. And with Live Framework, Live Mesh, with Microsoft Sync Framework, with FeedSync, with the whole services platform, that's what we're starting to deliver. And so what I want to do in the next hour is just tell you enough about synchronization so that you know how to go get started with these pre-release bits to build that same kind of application yourself. We could go way, way deep. We could have a 600-level session for a really long time about synchronization. If you're interested in that, try to catch me afterwards. I'm going to try to really kind of keep it crisp and tell you the stuff that you really need to know. So I've tried to keep a very good slide-to-demo ratio. There's just a couple things I want to talk about, but I really try to reserve most of the time for demos. And in fact, I'll sort of split it up into two parts. The first part is a little bit about the theory of FeedSync and just how it works in principle. And then I'll spend a bunch of time walking through a really concrete example of synchronizing data between a client app that I have and Live Mesh. So FeedSync, I'm sure you all saw the keynote. It's really an example of the kind of approach that we took to solving the software plus services problems that we faced. It's comprehensive, simple, and open is what we talked about. It's comprehensive in the sense that FeedSync supports any kind of synchronization architecture. You can do hub and spoke, you can do multi-master. It's as flexible as you need it to be. It's very simple because we took existing technologies like Atom and RSS feeds, and we said, what's the minimum stuff that we can add? What extra capabilities do you need in order to make synchronization work? Obviously, it's open in a bunch of ways. It's built on top of feeds, which are a really well-known technology. There's lots of great tools for using them. On top of that, the spec itself is actually a Creative Commons specification, and it's covered by the Microsoft Open Specification Promise. So we really want to see a lot of flourishing implementations of FeedSync. So if you think about the scenario that we've been talking about all week with software plus services, it is really, how do I have this mesh of devices? How do I connect these things and have my data move around to the different devices so that I can really access it anywhere and so that I can share it with people who are also accessing their data from anywhere? I wanted to pick something a little more concrete. So imagine, let's talk about sort of in the FeedSync specification, we use a grocery list. So I'm going to talk about that as a particular example. Very simple. It's custom data. It's not pictures, so hopefully that'll make you happy. But before I actually dive in, I wanted to talk a little bit about why synchronize. I'm pretty sure that everybody in the room has written a lot of applications that move data around from one PC to another, one server to another. I'm pretty sure you know how it's done. So why do I need sync? Why do I need FeedSync? There's really 4 requirements. So when we talk about anywhere access, when you imagine that triangle of the cloud and my PC and my phone and any other devices that you want to sprinkle in there, the first requirement, I said there's just 4. The first one is just that you want to be able to create new items anywhere in that mesh of devices. It seems pretty simple, but obviously if I'm at the store or let's say I'm at a conference and I'm not getting great reception on my phone, I still want to be able to enter data. I shouldn't have to have it connect to a server just to create new items. Likewise, sometimes my PC is disconnected. Same reason. So it's an important capability. The second one is just that every one of those items I create needs some kind of universal ID that I can use to identify it in the mesh. And again, seems pretty straightforward, but I need to be able to reason about those items and tell the difference between one and another when they're all shuttling around. They may be created at different times, different places, edited on different nodes at different times. And so that universal ID that we call a sync ID, that's the thing that I use to identify it. Another really important aspect of building a real-world mesh of devices that are exchanging data is that I have to be able to know efficiently when things go away. So if you are familiar with the way feeds work, if you have an RSS feed reader or an Atom feed reader, typically what it's doing is it's going to the server. It's saying, tell me what's new. And the server comes back with a feed of all of the stuff that's either changed or added. But it doesn't say anything about what's been removed. And so the only, so far that, the way you would sort of work around that is maybe just by saying, give me everything. But you can imagine if you have this mesh of devices and some of them are kind of slow, and you may get more and more and more data as you accumulate it, you don't really want to be have all of those nodes saying, give me everything you have, all of the time. And so what we've added is an efficient way for one endpoint to tell another one, hey, this thing's gone now. Again, a lot of these things are pretty simple, but they're important to make the system work. And then finally, this is really the big one, is when I have those devices, so I've got the web access, I've got the desktop access, I've got access on my phone, guaranteed I'm going to be able to edit things effectively concurrently. So in between the time that two devices sync, I'm going to change it on two of those devices. And of course, when I start sharing those items, so if I have a shared grocery list that I'm sharing with my family, friends, whatever, then of course, you can be almost guaranteed that some of us are going to edit the same item at the same time. And there are a lot of mechanisms, again, that you all know for dealing with that situation today. But the most important thing when you have this really somewhat chaotic device mesh is that we never, ever want you to lose data. We've got to preserve the data that comes from anywhere. And so we have a mechanism for doing that. So we can handle concurrent edits with FeedSync, and we never lose data. So those are the four big ones. Let me switch back over here, and let's see if we can walk through that concrete example. So I'll put the photos away for now. Get rid of this. And we'll come in here. So this is a feed. Hopefully some of you have seen something like this before. One thing that I was discussing yesterday is that the reason that you choose a feed as your data model isn't really for efficiency, because that's my payload that I just highlighted in the middle right there. And you can see there's a lot of stuff around it. But the big advantage, and this is one of the reasons why we built FeedSync on top of feeds, is that it's a very well-known interchange format. So I could do a lot of this stuff in binary, but obviously nobody could read it. And when we've actually used FeedSync quite a bit now in practice. We have some real-world applications. Live Mesh is an obvious example. And so this is a case where you just don't want to worry about pre-optimizing. In general, we can still make this work out very well. But here's my basic feed. I've got the normal stuff that you have in a feed. I've got a title, an ID. Every item in my grocery list is going to be an entry in my feed. And there's a bunch of fields there that tell me about that stuff. Let's take a look at what it means for this feed to be a FeedSync feed. So I've got all the data that I would have in a feed. And then in each entry, the thing that I add is this SXSync element. And so we often refer to this as SXSync. Sometimes we call it sync metadata. It's that extra stuff that you add to every item that you're synchronizing that tells us how to synchronize it. And so I've tried to abbreviate some of these things just to make it a little easier to read. But let's actually talk about those four requirements again. So inside the SXSync element, I have an ID. This is the thing that we call the sync ID. And this is the thing that uniquely identifies that item wherever it is on any device. So you can imagine typically it would be a little longer than this. Usually we think about it as maybe a GUID. It doesn't have to be. We actually didn't want to require, there's some environments, JavaScript, maybe really tiny devices, where you'd have a hard time generating one. So the base requirement is just that it's got to be something that's unique. I talked about having an efficient way to identify deleted items, and that's what this deleted attribute is for. So when I delete something, I actually still, we call it a tombstone. I still provide that item in the feed, but the SXSync element tells me if deleted equals true that that item is actually deleted, and so I can use that knowledge. And then really everything else that you see in this element really exists to handle the requirement of concurrent editing that I talked about. So there's an updates attribute, which is really kind of a version stamp. There's a history element, and I'll have more of these as I start to edit the item. And we simply tell you there's a sequence attribute on the element that tells you which one this is in the sequence. And then we have two things here. We have a when attribute and a by. And these are actually interesting to consider. So again, these are here for dealing with concurrent edits. Let's talk about the by first. What the by is it's sort of roughly, it's which endpoint made the change, made the last change to the item. So it's intended to be unique. The by is intended to be unique, but it also, it's not necessarily just a per user thing. You can see I've added in desktop. Right? So this was created by me on my desktop machine. On a different device, on my phone, I would actually have a different by. And the reason is because if I have successive edits, if I am assembling items from different places in my mesh, then if they have the same by, I'm actually going to just assume that the most recent one from that by endpoint kind of wins always. And so if you're thinking about conflict preservation, if you want to preserve data in this system, then we preserve that only across different values of the by element, or the by attribute. And then the last one is also interesting, the when. This basically, it's just a timestamp. But it's easy, when you're talking about synchronization, it's really easy to think, oh, there's the timestamp, that's how I know if the item's changed. We really mostly just use this for a convenience feature. We use it in one place in the algorithm, and it's really, if you know one thing about FeedSync, it's important to know that we don't use timestamps to tell the difference between two items. If you've ever tried to look at two PCs and figure out if they have the same clock or actually get them to have the same time, you know it's an impossible task. And of course, if you were able to set them to the same time, pretty much as soon as you did that, they would drift out of sync again. And so we basically, when we're looking at conflicting items, we use that just as an approximation to pick which one we want to call the winning item. But the thing that we really use is we use this version history and we use updates to tell us when things are in conflict. So that's basically, the way that I'd create a sync element is to just go ahead and add the sync metadata to an item in my feed. Now, if I want to update it, then I need to do a few things. There's some things you would naturally do to a feed whenever you update an element. And so, of course, I would change the updated time. So I might say this was updated at 8:30. And then for the entry, I'll also say this was updated at 8:30. And then I'm going to actually update the data, right? So instead of chocolate milk, maybe I'll just say skim milk. And so far, I've just been changing things that are actually part of that feed. Let's change the sync metadata, too. So what I do is I say, I've added another update. Oops, so that went to the wrong place. OK, so updates now equals 2. And I'm going to add a history element. So new sequence, new when, and I'll leave the by the same because I'm editing it on the same node. So that's what the effect is on a feed when you update the item. Typically, you might actually generate this from your database, from whatever store you have. But that's what it boils down to in the feed. And we'll actually see that in the demo as well. So that's how you update something. Now, I might take this item, and let's say I'm sharing with somebody. So there's going to be somebody else who's editing this item. They're actually going to update it themselves. So let's add another edit here. So we'll add a new history element. Let's say it was updated at 8:31, and it was updated by Steven's evil twin on a phone. So somebody else edited it, and they said, you know what, I really actually wanted the chocolate milk in the first place. And of course, you would edit the other timestamps in the feed. I won't bother doing that as well, because we're mostly interested in the sync metadata right here. But now, this is a case where I've got one edit that happened on the phone. I've got another edit over here that happened on the desktop. And so one of the important things about FeedSync is that we have a set of very specific algorithms that tell you, okay, if you're collecting items from a phone, from a desktop, we tell you exactly how to reconcile them so that you get the same result on every single endpoint. And so in this case, if I had this item over here in this window, and I was syncing it with this one, what we would basically do is we would look at the version histories. We would say, okay, the only difference is that the newer, this item that I just changed with the chocolate milk, it's got every single version history. It's seen every edit that the original one had, but it's got one more. And so we basically call that subsumption. We say this new item subsumes the other one. When somebody edited that back to chocolate milk, they saw those other edits. They saw that, yes, it was at skim milk, but I'm changing it. And so that one basically wins. And so when the system syncs that item, every node is going to say, okay, this is the winner. There's no conflict. There's no ambiguity. This is the latest state. And so that chocolate milk is going to be trickling around my mesh, and I'll be very happy. But what happens if, I actually tried to edit that? Let's see. So at the same time that my evil twin was editing that on my phone, I'm going to actually edit it over here from my desktop, and maybe I'm feeling a little, strange or something, and so I want the strawberry milk from the Strawberry Quick, if you all remember. And so let's say that happens at, almost the same time. Let's say it happens at 8:32. It was by me on the desktop again. But I don't sync for a few minutes. And so effectively, it really looks like these two edits happened at the same time. So now if let's say I push them up to the same website, let's say they're all going to Live Mesh. Live Mesh says, all right, you've got one edit here. And it's got updates equals 3. It's got sequence equals 3. It's got this particular version history. Now you've got this other item. Oops, and I forgot to update updates. So it's got updates equals 3. And it's got this particular version history. And it's going to be able to compare the version histories and say, okay, there's something missing here. These don't actually match up. You've got one edit and another edit that are in conflict. And so what happens at that point, I told you that we preserve data. We do a pretty straightforward thing. There's a specific algorithm that tells you how to pick a winner. So we basically just decide that, okay, one of those has to be sort of the winning item. And in this case, it's going to be the first one. It's got a slightly later timestamp. So what we do is we create a new node, and inside SX sync, you have an SX conflicts element. And like I said, it's pretty simple. What we do is we take the entire conflicting entry, and we just shove it in here. So now I've got my winning item. And so for anybody who's looking at this thing, they don't actually have to be, you can let those conflicts percolate around. You don't have to pay too much attention to it if you don't want to, because you still have a perfectly valid feed item here, right? It's got all the data that I need in the feed. It's got an SX sync. It's got a history. It happens to have a conflict, but, no pressure. If I do want to pay attention to it, then I can actually open that up and say, oh, okay, I've got two conflicting items here. And typically what I'm going to do is I'm going to, it doesn't happen that often. What we typically recommend is that when it does happen, you just present it to the user. So you say, hey, you've got the chocolate milk one over here. You've got the strawberry milk one over here. Which one do you want? And so the user can say, hey, whichever one I like better. The important thing is that you need to make sure the reason that we preserve all of the data is because you want to give the user enough information to make a logical decision. There's nothing more frustrating than having the computer tell you, hey, did you want item A or item B, and not really knowing why or how you should pick one. So typically, it's really helpful. Again, we preserve all this info for you. And in fact, you can add, it's just a feed, so you can add extensions yourself. Typically what we'd say is, you edited this one on the phone at this time this way, and you did this one on the desktop, or your evil twin did this one. So you know who did it, who made the change, when they made the change, and you know what the change is. And so in this case, let's say that I agree with my evil twin. I really like the chocolate milk idea. So what's going to happen is the way that I resolve the conflict is to issue another update. So we'll walk through. We'll say this one's going to happen at 8:40. I'm going to put the data in here. And we always edit the winning item. So it doesn't matter where the data comes from, but you always issue this as an update to the winning item. So let's say we'll actually update this timestamp for real, 8:40. And what I'm going to do is I need to merge the version histories. So I'm going to take this one, which is the one that they don't have in common. I'm going to add it to the winning item's version history. And so now anybody else, it's important to do that because anybody else who's seen these edits can look at the version history and know, oh, okay, I've actually seen all those changes too. And then we simply get rid of the conflicts element with its entry. So we're kind of back to normal now. And I need to do a couple more things. I need to change updates. That's going to be 4. And I will add a history. And that's going to be, what did I say, 8:40, I think. Sorry? Oh, thank you. Bad typing skills. And then this was actually me, not my evil twin, I think. So I will say Stephen, my desktop. So there you go. So now I took that conflict, I showed it to the end user. I said, hey, which one did you want? Here's when they were changed. The end user, that was me. I picked one. Now I've updated the item, and this is the new item that's going to percolate back through my mesh. And because I've got the complete superset of all the version histories, anytime this, so you could have a fourth party over there who's seeing all of these items floating around together and says, oh, okay, this one's really the winner because it's seen all of the version histories and all of those other items. And that's pretty much how FeedSync works. It's interesting to note that you can have as many conflicts pile up in there as you want to. So you can carry around a bunch, subject to whatever reasonable limits you think there are. Again, we really want to preserve all of the data. And then the last interesting thing to mention is that you don't actually have to, the history can really grow as somebody edits these things. So you only really need to keep the last history per writer. Let me make sure I get this right. So yeah. So basically, I can shrink that down so it's just got the last edit for me, the last edit for my evil twin. And so that's basically FeedSync. Okay. So, no, that didn't work for me. That was kind of the abstract version of it. Let's switch gears now and talk about a really concrete example. So this is I've actually got that grocery list for real. How am I going to, push that data around my live mesh? And I chose a specific example. I hope that some of you got to see the live mesh application session yesterday. The example I have is that I've got a website or a client app. We'll talk about why a website's particularly interesting a little bit later. But let's say I've got a site or a client app kind of up top there. And I've got an existing data store. So maybe I had a grocery list client app. Maybe I had a little website that was tracking groceries. There's a bunch of data that already exists. And so what I want to do is show you exactly how you can take that data or a subset of that data and actually push it into live mesh on the cloud and then manipulate it with a mesh-enabled application so that as that data flows around the mesh, you'll have that mesh application editing it, on the Windows desktop, eventually, on the Mac client that we have, on the phone client. So you can see that it's a compelling example for a website, because if I just have my data on the web, this is a great way to get reach out to somebody's device mesh, to all their devices. They can actually, just as I showed you with the photos, they can start to edit data offline on any of those devices. We'll synchronize that back to the Live Mesh cloud, and then you can synchronize that back to your service. There's a bunch of different ways. Again, you've probably seen from maybe the talk about how to access Live Mesh from non-Microsoft tools. There's a bunch of different ways you can talk to Live Mesh. I'm really focused on the two in the middle. You can do kind of straight HTTP if you choose to. There's definitely going to be some great ways to use Microsoft Sync framework to access it. It actually works today, but we're working on making that story even better. I'm going to focus on the middle part with the FeedSync client and also the Live Framework API. And we'll sort of explain the pros and cons of each of those as we go along. All right, I'm back. So let me close out of here. Sure. So what I've got to start with is I've got a client application. Like I said, it's certainly probably at least as interesting to do this with a website, but for visualization purposes, it was a little easier for me to show you what I wanted to show you. So I've got just your basic app here. It tracks grocery lists. Hopefully, all of you have written this a million times. Let me just show you my simple database here. So, normally this looks pretty familiar. I'd have an item ID, and I apologize, that's a little small. Let's see if we can. There we go. So, kind of your normal simple table. I've got a primary key, that's my incrementing ID. I've got the actual item, that item text. I have the XML, I have the sync ID, and then I have the item XML, which is actually the full XML entry for that item. And you can see that what I've done is I've pulled some information out of the XML and kind of cached it in my database. So I have the sync ID, I have the isDeleted flag, so that I can easily check those from my database row. So if you think about how does supporting FeedSync affect my existing application? Most people probably aren't doing an app where all of their data is stored in feeds, and you have no database representation. If you were doing that, then all you really need is that item XML column, and you're good. You just stuff the XML in there. I'm assuming that most of you have some kind of structured data store, SQL, something. And so this is a little more typical example of what you do. You have all the data you have today, plus you have the XML for the item. And one big reason to do that is because it makes it a little easier to store things like conflicts. If there are extension elements in the feed, I'm not going to know about those ahead of time in my database schema, right? And so this gives me a bucket to put things like XML extensions. But even with that XML, it's still really useful to basically promote some of those fields out of the XML into my database. And that's what I've done here. So that's that. Let's go ahead and fire it up. I want to set some breakpoints in interesting places. Let's see. Well, let's set one here when we're going to sync. Oh, already got one. Even better. Let's let it rip. So here's my grocery list client application. Let's fire up the mesh application. And just in a little homage to the new platform, I chose Azure as my background color. Just a little different from the default, but. And so I'm actually using, hopefully you've seen this in some of the other sessions, I'm using the new Visual Studio tools that target the Live framework. And so when I hit F5, there's going to be some gears turning, maybe some mice on a treadmill, I think. In all seriousness, it's going off. It's actually pushing my application into the cloud. And I really, if anyone from that team is in the room, I really want to thank them because this is way, way better than what we were all doing before, trying to do this by hand. So as much time as that takes, it's still saving you a ton of time that you'd be doing all those steps manually. So I ran it. it compiled my application, pushed it up into the Live Mesh cloud, and it's actually attached the debugger. This is a Silverlight application, so now I'm debugging this one too. And again, with the mice on the treadmill. One of the advantages of having the folks actually who built this stuff come to the show is that they often sit in the audience and they tell you afterwards, oh, I've already been debugging that and we're working on it. So, and of course, as other people have mentioned, the real target is actually to be able to debug these things on your local machine. So it'll be quite a bit faster once we get to that point. In the meantime, I get interesting messages. I think you can. Well, we'll give that a sec to come up. Let me switch back. So here's my client application. And I've got a button here that allows me to show the feed. So I have no items yet. So all I have is an empty feed with just the feed level information. So what I've done is if I add something to my grocery list, let's say I add milk, then I'm adding that item to my database. I'm actually creating an entry for it in the feed at the same time. And so that I can show you that just as I showed you in Visual Studio, just in the editor, I've added an item. I'm actually using RSS feeds instead of Atom. We work interchangeably with both. And in fact, Live Mesh allows you to grab either an Atom representation or an RSS representation, or even JSON or POX of the same data feed. So RSS is just there's a little less stuff to show you, so it's kind of handy that way. So here's my RSS item that I've created. You can see I've got a real sync ID and all the other stuff that I showed you. Let's come back here. Much better. So here's my little mesh application. So this is Silverlight. It's actually living inside Live Mesh. And I'll show you some of the code differences that result from that in a sec. But in the meantime, let's go ahead and add something else, maybe the eggs. And I will click the add button. And there we go. So now I've got one item over here, and then it's living inside Live Mesh. I've got another item, wait a sec, over here, and it's living in my client app or my web app. And so let's hope that breakpoint works for me. I'm going to hit the magic sync button, and let's see what we do. So in principle, right, I've got a FeedSync feed here. It's got my item in it. It's got the sync metadata. I've got a FeedSync feed here, and in fact, you can see that when I click on that guy, I'll pop up the sync ID down here. And for those of you who are familiar with the resource browser that's part of the SDK, if you're not, you will be soon. So I'm going to dive into I'm looking inside the Live Mesh store right now. And so I'm looking at my mesh objects, and I'm going to squint a little bit. So right here is the object from my mesh application. So we'll look at the data feeds, and I'll look at the FeedSync feed. And so let's zoom in a little bit on this one. So you can see I've got a feed, and then this one has that one item. And where is it? There's my eggs. OK. And you can see Live Mesh actually adds a bunch of extension elements that I don't have in my app, and that's OK. So I showed you before how, sort of by hand, I synchronize those two feeds. So in principle, what should I do to synchronize these things? Well, basically, I need to, merge the feeds. I need to push the stuff from my client app into Live Mesh. I need to grab the stuff from Live Mesh and bring it back to my client. And in fact, that's exactly the way it works today. So Live Mesh, something that we may have in the future is an ability for Mesh to actually, on some schedule, reach in and grab stuff from your app. But for now, it's actually driven from the outside. So my web or client app is going to sort of be responsible for the push and the pull. So let's come back here and see if we can hit that breakpoint. So here's my sync button. OK. So the first thing I want to do from my app side is I'm going to connect to the cloud. And so I'm basically using the live operating environment just to go and find the feed for my application. So I'm actually using Windows Live Authentication here. I will just wait for a sec while it talks to the cloud. OK. I'm going to find my mesh object. I'm going to use a link query to grab the one that matches my mesh object name, which was the grocery list. And then I want to grab the particular feed. And so at this point, I actually have, inside my app now, I know the URI for the data feed where the information is stored in live mesh. And that's the stuff that you saw in the resource browser. OK, so I connected to the cloud. Now, actually, the model works pretty much the way that I described. So I want to post the feed. So I'm going to take the feed that I have inside my client app. And what I'm using to build my client app is a little library that Parrish in the second row here actually wrote. And it basically sort of encapsulates all of the stuff that I need to do sync correctly. So this is also something, so the sync framework implements FeedSync, so you can take advantage of that. Obviously, live mesh does. We'll see that in just a sec. This is definitely something, it's not that hard to do, but you really don't want to do it more than once. So if you end up writing an application like this, feel free to write your own library, but then you really want to reuse that as much as you can. So I'm actually going to use the syndication client API so I'm taking the feed from, I'm stepping through here. I'm taking the feed from my own internal library format. I'm converting it to the syndication feed format that's supported by WCF. And then I'm actually going to use the FeedSync client API that's part of the live framework. And I'm going to post that synchronization feed, syndication feed up to live mesh. And that's what I just did just now. And if all succeeded, and it did, I actually get a return feed which shows me the result of what I posted. So at this point, I should actually have all of that stuff in the cloud now. Now what I want to do is get the items from live mesh and bring them back to my app. So I'm going to go ahead and get the synchronization feed. It's pretty similar stuff. What I did was I used the syndication client API to grab a syndication feed, and then I just converted that to my library's native feed format. Here's where some interesting stuff happens. I showed you in the resource model browser that there's a bunch of stuff inside the feed that my app doesn't preserve. And that's OK. But I actually want to sort of remove that because I don't want to store more than I have to in my application. So it's actually perfectly fine. We have this notion of the difference between what we call publisher-specific data and mesh data. So the idea is that when you're syncing a feed, there's stuff that, we actually have a pretty careful definition of what it is, but there's stuff that you care about, and that's really the data payload. And there's stuff that you're going to find in a feed, and you're perfectly free to remove that stuff. So what I've done here is I've just written a little routine that's using the XElement class, and I'm removing the stuff that I don't care about from the feed. So we'll go ahead and just step over that part. The specific reason why I bring this up is because it's important to note that when you are changing a feed and you're changing the mesh data, you're changing the payload, then you always have to update the synchronization metadata, right? Because that's the whole point of it, is that every time you make a meaningful change to the data in an entry, you've got to update the sync metadata. For the stuff that I sort of said I don't care about, that publisher-specific data, it's OK. You can go ahead and pare that away. The sync metadata is just fine because you're going to not publish it back out anyway. So that's what I've done here. And now finally, this is sort of an artifact of how my library works, but I've actually merged the two feeds. And so now I need to take any items that show up in my feed. I've got to add them to my local database. So that's what I've just done right here. I'm going to update my UI, and ta-da. Thank you. So here's my client app. I just synchronized the data. Here is the web app. And I just need to give this a little nudge to update. Oops. There we go. Woohoo! So now I've got the data on both sides. Let me sneak in here and set a breakpoint. Well, let me show you real quick. On the client app side, here's what it looks like when I edit one of my items. I'm actually just going and finding the RSS item that I'm editing. So this is an item in my library. It's called the FeedSync library. And so when I edit that thing, I go find the corresponding entry in the feed. And I've got, as I said, I've got this library that's actually updating the synchronization metadata. So it's an explicit step for me. I've changed the data in the UI. I've changed the data in my database. It's also an explicit step, on my being outside Live Mesh. It's an explicit step for me to update the synchronization metadata. And that's what this library is doing for me. And it's doing the same stuff that I showed you back in VS, just doing it by hand. I've just got the library doing it. So let's take a look. When I go and edit something in the Mesh-enabled web app, let's see what happens there. So I'll just go ahead and set a breakpoint right there. And let's go ahead and, I guess I have this, oops. Come on back. There we go. All right, so I have this thing about, all right, I'm going to back off for just a sec. There we go. Okay. Did I mention that the developer CTP is actually open to everybody? So there may be a few people using it. So I've got this thing about chocolate milk this morning. So I'm going to take that milk item, I'm going to change it to chocolate milk, and this is inside the Mesh app. So I didn't actually show you, but let's go ahead and edit this thing. I don't actually have my own data store inside the Mesh application. I'm just using Live Mesh. I'm just using that feed to store the data for me. And so if I go and look at the resource model browser, let's refresh it. OK, so if I come to the right place, right here, you'll see that I've got this item. It's got the data, milk. It's got some sync metadata. It's just got one update, because I just created it. And that is, you're looking at the actual data store for my Mesh application. So I'm just going to step in here, and this is pretty simple. I have a bunch of logic to go figure out if I've got a decent index and the, oh. That was interesting. Let's try that one more time. OK. Anyway, so I've got a bunch of logic that just handles the fact that I'm trying to line up the UI, which obviously didn't line up quite right. So let's go ahead and hook up the debugger again. But the interesting part, if I can show you, the interesting part is really right here. So I use a link query again to look at that feed, and I want to find the item that I'm editing. And then right here, I've got that item, and all I'm going to do is update the data with that one line. And then I go and tell Live Mesh to go ahead and post that update. And that's it. I don't have to explicitly worry about sync metadata, because that's the whole point of Live Mesh, is that it deals with that for me. So you can see it's a little simpler. Again, that assumes that this is my Mesh application. It's living inside Live Mesh. You can actually do the same thing from outside. So I can use that same Mesh API from outside the cloud. But again, it actually needs to be connected to a live operating environment, whether that's a local one, whether it's the cloud one. The advantage of kind of doing the sync work myself in my application is that I don't have to be connected to any aspect of Live Mesh. I can just maintain my store, maintain my feed, and whenever I do get connected, then I can push the data over. So let's see if we can get that to work again. Maybe I'll actually go the other way. So let me bring my client. So I'm going to change that to chocolate milk. I'll hit the edit button. And if you look at my feed down here, you can see that I've changed the data in my feed. Let's go ahead and try to sync that one more time. So we'll connect to the cloud. We'll post the feed. We'll go ahead and grab any new stuff from the cloud, just as we did before. OK. And so if all goes well, I did mention it's a CTP. OK. If all goes well, I'll hit my secret little update button. And so it's actually going to update the UI from the feed. Almost worked. I think I got myself out of whack somewhere. But basically, it actually picks up that update. And of course, it should have just updated the milk to chocolate milk. So that's pretty much it. That's kind of how you synchronize data. Let's take a look at the resource model browser and see what happened there. I should have an extra entry now. Or maybe that was just an artifact. OK, so actually in the resource, it's just my UI. In the resource model browser, you can actually see that the real representation of the data just has that updated item. So it worked. If you don't, yes. Thank you. I'll take questions in just a sec. So let's go ahead and see if we can close that, reopen it. Maybe it'll be happy this time. So what I showed you was, I've got my own data store in a client app, in a web app. I'm actually doing that kind of manual process of pushing my data in, grabbing it out. Probably, in a real-world example, what I'll do is I'll have some kind of process timer. So every now and then, every half hour, every hour, I'll actually do that synchronization step. So it'll just be an automated process. The thing that I still do want to do in my mesh client is because somebody can be pushing in changes, because there's changes from other mesh clients. If I'm collaborating with people, if I have shared out the data, then stuff can be changing under me. And so what I need to do on my mesh client is I still need to have kind of a timer process that updates the UI as new items come in. And maybe that'll happen here. Couple things that I was going to show you but didn't was just, of course, if I have an item here and I delete it. OK, so I have an item here, the eggs. Let's say if I delete that, I made it disappear from my UI, but you can see that it's still here in my feed. And it's just as I showed you before. All we did was we set deleted to be true. And in fact, if I turn on the show deleted items flag, you'll see it's still there. And again, the reason is because when I push that feed around the mesh, I want the tombstone for that. That's what it's called once it's deleted. I want the tombstone to go to other endpoints so they can all see that I've deleted the item, and then they'll delete it as well. So see if we can tempt fate again, and I'll actually sync that deleted item. We'll just let it rip for a sec. So I'll sync that off to the cloud. Looks like it's synced. And so that'll actually disappear in a sec, too. So all this stuff that we showed you kind of in theory actually works in practice, too. It's pretty cool when that happens. And so that's kind of synchronization. So the other thing I didn't quite get a chance to show you here is dealing with conflicts. But that really works pretty much also as I showed you in the theoretical example. So if I were to update two items on these different endpoints, roughly at the same time before I sync, I'll get a conflict. We'll actually capture that in the feed. And you can actually, as I said, you could display a UI that shows both items and allow somebody to pick them, push the update, and that'll sync across as well. OK. So it's kind of tough to cover. We've been working on this for a pretty long time. It's tough to cover absolutely everything in just an hour. So if I had a part 2, which I don't, but actually a lot of this is covered in the other live framework sessions. So if I had a part 2, I would talk about things like delegated authentication. So I was actually just using my own credentials to talk to the cloud right there. For a real application scenario, you'll want to use delegated auth, I think the way that Arash showed yesterday in the mesh application session, so that you're actually getting explicit consent from the user to access their data. I would also talk about efficiency. So, in my simple example, I'm actually pushing the feed over to the cloud. I'm grabbing the whole feedback from the cloud. There's a pretty simple mechanism that Live Mesh uses to just send the changes. It uses something called entity tags in HTTP. So you can just do the change tracking on your side, just send a feed, basically a partial feed that represents only the new stuff, push that up to the cloud, and then you can actually get from Live Mesh a feed that has only the changes since you've last synced. And that change tracking on the client is also something that Microsoft Sync Framework does really well for you. I would talk about enclosures. So the thing that I was syncing was just a really simple item. And you can actually do the same kind of thing if I had a file folder. You can basically navigate around the resource browser. And I have an empty live folder here, but basically you can look in the data feeds. Oh, thank you. So you can look inside the data feed for the live folder, and it's got a FeedSync feed just like the one I was showing you. Each file is represented as an entry, and then there's actually an attachment. There's basically an enclosure for each file, and it's pretty straightforward to synchronize those as well, something we didn't get to cover. So then we did talk about conflict resolution today. The last thing is just that the data format is a really important thing to consider when you're trying to set up a sync system like this. The thing I showed you was just using the title to carry all my data. I'm guessing, and you could kind of see that reflected in the database in my application, I'm guessing that most of you have a slightly more complicated data model that you're trying to synchronize around. And so there's a way basically to take all of that content. And once you've defined a feed format, so once you've figured out how do I boil that down to something that I can represent in a feed, then you can actually store that data in a content section of the element. And when I talked about the difference between publisher-specific data versus kind of your mesh data, that's your mesh data. That's obviously can be a more complicated data model. So some interesting resources you can take a look at. Obviously, you'll have access to these slides off of the Microsoft PDC site, so you don't have to scribble it down. But feedsync.org is where we have information about FeedSync. The FeedSync specification, I will actually work on cleaning up the samples and posting those there as well, or at least a link to them. The Microsoft Sync framework is found at msdn.microsoft.com/sync. Obviously, on dev.live.com, you can find out about the Live framework. If you haven't already, definitely encourage you to take a look at that. And then on my blog, I will try to post a little bit more than I have recently about kind of how to follow on from this session. So just want to remind you that there's a couple more sessions on Live Mesh, on the Live framework today. There's one in 4.11 on the Live Mesh and devices that's going to be really great. And then back here at noon, there's a session on notifications and awareness and communications, and there's a really killer demo that you'll all want to see. So definitely come and check that out. And so 2 things I want to say before I take questions. Number 1 is please do fill out the evals. We really appreciate your input. And number 2 is thank you very much for coming, and I'm happy to take questions. But please come to the microphone if you have a question. Yes.
You were making the point that the app decides when to initiate the sync. And in the demo, you were updating one side and then updating the other side. I understand that for newly added items, but can you not also register for notifications so you'd get a news event when something new is added?
So the question is, can you register for a notification? Live Mesh does have a mechanism for registering for notifications, so you can actually set up a notification queue for a particular feed, and you can basically get a notification from Live Mesh. Right now, what you're actually, it's going to evolve over time. This is sort of in a pre-release state. But yes, eventually you'll actually be able to get a notification. Right now, what it gives you, what the notification queue gives you is a central place to look for changes on all the feeds that you care about. So instead of having to look at, say, 10 different feeds, you can actually just go to one place to pull for the changes on all of them. On your side, obviously for your application, you can have any kind of notification mechanism that you want to.
Okay, thank you.
Cool. Over here?
On the local machine or the local mesh client, you had something called a local format or a local feed format, and I didn't quite get what that was all about.
So you mean when I was showing just this feed right here? Is that the one you're talking about?
Well, you were in code and you were.
Oh yes, I'm sorry.
You were
Okay,
talking
now I
about-
understand. So inside the live framework, there's a client API that helps me, basically sync data to and from actually any to and from live mesh with syndication feeds, which are something defined in WCF. So WCF has a model for a syndication feed. I have a FeedSync library that I'm using in my app that does FeedSync that just has a slightly different internal feed format. It's just something that I haven't aligned yet. And so there's a bunch of code in places that you might see that's converting from one to the other. It's just sort of an artifact of the implementation. Cool. Back over here again?
Yeah, my question is around the sync framework.
Yeah.
If I'm understanding this right, you showed something a little lower level than that, and then they've got a framework that wraps it and provides value add. Is that correct?
So what I was doing was really trying to show kind of a bare bones example to show how FeedSync works. And so I have a really lightweight library that's doing kind of the essentials of a FeedSync implementation.
Right.
Sync framework supports FeedSync, but it's really it's a sort of a very full-featured framework for doing synchronization. And so there's huge value add in terms of doing change tracking, change enumeration. In the CTP that they've released, they do great metadata handling for you. So their job is to really make it easy for you to implement synchronization. So if you think about it, the core values there are doing things like maintaining the sync metadata. And it's actually the same metadata that we use both for FeedSync in our specification and sync framework in the implementation. So they basically abstract away a lot of that stuff and do huge amounts of work for you for handling things like efficiency, for handling multi-point sync. And then on top of that, they support basically converting that data into multiple formats. And FeedSync is sort of the out-of-the-box format that they support. If you don't want to write your own, you can automatically take a sync framework, sync provider, and create a FeedSync feed from it. So it's a little bit of that implementation versus specification difference that we're talking about. I had a really lightweight implementation just to kind of show you how the spec works. They actually have a full-featured product which also implements the FeedSync spec.
Okay, that's clear.
Okay.
Just a follow-on question, though. For
Yeah.
the framework, then, would there be a way to deal with detecting a presence? For example, if I'm working with your desktop grocery list,
Yep.
and the network goes away, right? I'd like to trigger synchronization automatically whenever the connection comes back on. Do you know if the framework would support an event that would tell me that the network's back?
The sync framework itself doesn't really deal with sort of communication protocols. It's really handling the work of sync. And so the task of moving the data from one place to another is up to you. But there is support. I know at least in VB 2005, we had support for basically getting network change notifications. I think that's something that's baked into the .NET framework. And if not, you could probably access it anyway.
Okay, thanks.
So I think there is other framework support for that scenario.
Thanks.
You bet. Over here.
Yeah, in the scenario when we want to move content peer-to-peer and not through the cloud,
Yes.
should we attempt that with this simple model, or should we be relying on the framework?
I think it really depends on the scope of your application. If you're trying to sync data peer-to-peer, then if you don't have a ton of it, it's fairly straightforward to, you can write a pretty simple implementation of FeedSync and sync peer-to-peer however you want to. One of the examples that we actually designed FeedSync for was basically in situations where you don't even have a network. We wanted you to be able to stick a feed on a USB stick and just carry it around to people and have them plug it in, grab the feed, sync it, shove their data back on the stick. So it's really it's a very protocol independent thing. Having said that, I would definitely say that if you have a lot of data, if you're looking at efficient sync, I would definitely take a look at the sync framework, especially the new CTP that they have, because they've taken a lot of, that's the whole purpose, is that, they want to take the grunt work out of doing sync, abstract it away as much as possible, so you can just kind of worry about your own data and your own app.
Good, thanks.
Thank you. Over here.
Yeah, I have a question on the example you did. If we actually had enclosures, so if you had resource media,
Yeah.
and we had a conflict, and you resolved the conflict, and you took your evil twins, he actually won. Mm-hmm. But if there was an enclosure attached to that, and then Steven's evil twin side did the sync down,
Yep.
so now the update flag is set at 4. Does he know, just from that conflict, that the actual resource media is the same? Or, is there some optimization in the live operating environment where there would be a hash that would come across so that I wouldn't have to pull that file down again?
So currently, so you wouldn't have to pull the file down again. Trying to think through that in my head. So you could tell, let me back up a little bit and talk about, so the way we handle enclosures is that, you have the same metadata feed, like that one, let's say, and there's just a link that tells you where in live mesh that enclosure lives. So if you're trying to sync that down, so if you're talking about your own client and you want to sync enclosures, you've actually got to first sync the metadata, figure out what's changed, what new enclosures you need to look for, and then you need to go and grab them and store them in your own system. So when you're syncing the metadata, you can see that an item has conflicts, and you can actually tell whether or not the links to the enclosures are the same or different, right? So if you're looking at the winning link, it's going to point to one place. The conflict link most likely will point to another place. And so there'll actually be 2 different enclosures, one for the winning item, one for the conflict item. And in order to do it properly, you'd need to actually pull them both down because they'd be different. If they were, for some reason, the same, if there was a conflict but nobody had changed the enclosure, then you could actually detect from the link and say, I've got that resource already, and I don't need to pull it down.
Okay, so the link would actually change up in the live mesh side. If the resource did change.
To be honest, I'd have to walk through it and just verify, but that should be the case. Obviously, if the link stayed the same, yeah, there should be a different link for the winning item for the conflict item, but it's something I don't want to go and prove to myself by stepping through the code.
Okay, thanks.
You bet. Over here.
Do you have any guidance on the use of RSS here versus Atom and Atom Pub in SQL data services?
In SQL data services. Can you refine the question?
Well, you're both part, components in an overarching architecture, and
Yep.
they've been speaking a lot about Atom and Atom Pub and the adoption of that.
Yep.
I understand the evolution of FeedSync and where it came from, and I know you could translate between the formats, but if you're going to worry about it at the wire level, seems like you're going to have to worry about both.
If you're going to, you don't actually. It depends on your situation. If you are consuming data, if you're basically talking to live mesh services, if you're talking to SQL data services, they support everything. So you could choose to purely talk in terms of Atom, right? And I think one of the values of Atom and Atom Pub is that it's very well, basically the process of how you define the feed and how you actually communicate the feed back and forth is very well defined. Atom Pub is actually not what we, when I showed you syncing from my app over to Live Mesh, I wasn't actually using Atom Pub because Atom Pub is more of a client-server focused protocol, right? It says you can update an item at a time. You're always doing it directly to the server. There isn't this notion of sync metadata. I was actually posting the entire feed, so it's kind of a non-Atom Pub operation. It's really it's a merge semantic. I'm taking some full feed or partial feed, and I'm saying take all these items and merge them into your store, and then you'll have the result. So if you're thinking about sort of straight CRUD client-server data access, Atom Pub are definitely a good way to go because it's very well specified. In practice, what we've done, if you look at Live Mesh or SQL Data Services, is we've sort of plugged in RSS and JSON and POX into the same Atom Pub client-server mechanism. So you could still choose your format. But there's no hard and fast specification that says what happens there. We're just kind of adapting to it. For FeedSync operations, if you're really just looking at sync, it doesn't, you can really, again, just choose whichever one makes the most sense to you. Because again, you're sort of outside that client-server world already, if that makes sense. Hopefully it does. You can always grab me afterwards if I didn't quite get an answer to your question. Cool. Thanks, everybody, for coming again, and definitely, hopefully, you'll get a chance to check out the other presentations.